Hey guys, it's Rhett here. I've got a question for you today from the VCE Maths Methods course, Unit 3, and it actually is going to draw upon a bit of calculus later on in the question. So depending on your level of knowledge in the course at the moment, you might just stop at part B. But we're basically given a cubic function here, x cubed minus 3x minus 2. We're asked to find the x and y intercepts. The x-intercept is going to involve finding a factor and long division. The y-axis, the intercept, we're going to sketch the graph and label all the intercepts. And then the bonus part of the question is we're going to do some calculus to find the coordinates of each stationary point. Okay, so I might start with the y-intercept because that's probably the easy one. So y-intercept, I'm just going to let x equal to 0. So then f of 0, as we see here, straight off, 0, 0, negative 2. So 0, comma, negative 2 is my y-intercept. The x-intercept, I have to let y equal to 0. Okay, so I'm left with x cubed minus 3x minus 2 is equal to 0. And I need to solve this. Now, I can't do this directly. There's no way I can really factorize this just as it stands. So what I have to do first is the method of long division. So hopefully you've seen this for polynomials. So I'm just going to say, consider the polynomial p of x is equal to x cubed minus 3x minus 2. Now, I want to test this polynomial and find a factor. When I sub in this number, a value for x, I should get a 0 here. So, usually I just start off with something easy. So let's try 1. P of 1 is equal to 1 minus 3 minus 2. That actually equals negative 4, which is not 0. So that doesn't work. Maybe I'll try 2 next. This is just a trial and error process. So 2 would give me 8 minus 2 by 3 is 6 minus 2, and hey, what do you know, this is 0. Okay, great. So using this rule, therefore x minus 2 is a factor. Okay, so I've subbed in positive 2, but it's the x minus 2, which is the factor. So what this is going to allow me to do now is long divide this cubic polynomial and work out the quadratic component. So just note here, what I'm going to do when I'm setting up the long division is I'm going to leave a space here for the x squared, so I'm going to write 0x squared here because it doesn't have that term, minus 3x minus 2. That's just going to allow me to set up. Okay, so hopefully you've done a bit of the long division before, but basically what I do here is x into x cubed goes x squared times. Then I circle back around. X squared times x gives me x cubed. X squared times negative 2 is negative 2x. Okay, I draw a line here. X cubed minus x cubed, I should always get 0 at the start here when I do the subtraction. 0 minus negative 2 gives me positive 2x. Sorry, squared, and I bring the minus 3x down. Okay, now the process starts again. X into the 2x squared goes positive 2x times. 2x times x gives me 2x squared. 2x times negative 2, negative 4x. Draw the line, perform a subtraction 2x squared minus 2x squared is 0. Negative 3x minus negative 4x gives me positive x. Bring the negative 2 down. Okay, process starts again. It gets a bit repetitive. X into x goes once, one time. 1 times x gives me x. 1 times negative 2 is negative 2. And yay, what do you know? There is no remainder. So this factor went perfectly into my cubic polynomial and results in this quadratic factor. So the conclusion from all of this is that p of x is equal to x minus 2 x squared plus 2x plus 1. Okay, now hopefully you'll notice here that this is actually from a perfect square, and I could also use the diamond method to further factorize a quadratic here, but it actually simplifies down to this. X plus 1 all squared. This into this. Okay. So now, where were we? The whole point of this was to try to work out this x-intercept. So what I've done now is I've rewritten this as this. Okay. So the x-intercept is x minus 2, x plus 1, all squared, is equal to 0, which means that x equals 2 or negative 1. So this is the null factor law. Either this is 0, so x is 2, or this is 0, meaning x is negative 1. Now note here that this is actually a repeated factor. So this is one of the turning points actually for the cubic. So just write the coordinates here, 2, 0, and negative 1, 0. Okay, so that's the first part of the question. I've got both the coordinates now, the x coordinate and the y coordinates. Now just to save a bit of time, I've drawn up some axes here. So we're going to grab a pencil and do the sketch. So my 2, 0 and negative 1, 0 was the x coordinates, and my y coordinate was, if you remember up here, it was at negative 2. So here it's negative 2. Now this cubic graph has a positive sign here, so the cubic will have this kind of a positive shape, so it's essentially going to go like this, come down, and then go back up. So I'm just going to put a bit of a sketch in now to just show the shape and the important points. Okay, so that's the cubic, and then I just make sure that I label negative 1, 0, 0, negative 2, and 2, 0. And I just finish off by writing the equation f of x is equal to x cubed minus 3x minus 2. Okay, so that's part B. Now part C is the bonus part of the question. So if you haven't done calculus yet, that's the end of the video for you guys. If you have, we're going to use calculus to find the coordinates of each stationary point. So over here, I'll just put it part C. So f of x was x cubed minus 3x minus 2. Okay, I'm going to take the derivative. So f dash of x is equal to, 3 comes down, 3x squared minus 3. That's my derivative function, which is a quadratic. Now for stationary points, I'm going to solve f dash the derivative. Where does the derivative equal 0? Okay, so I have to solve 3x squared minus 3 is equal to 0. X squared is equal to 1. So x is equal to plus or minus 1. Okay, so I now have the x coordinates of my stationary point. I then sub them back into the original function. So f of 1 is equal to 1 minus 3 minus 2, which is equal to negative 4. So that's one of the coordinates of my stationary point, 1 comma negative 4. And the other coordinate is at f of negative 1. Put a negative 1 here, negative 1 plus 3 minus 2, and I get 0, which is actually that point we talked about earlier, negative 1 comma 0 being the repeated factor, 1, negative 4, and negative 1, 0. So I'm just going to come back to my graph here, and I did actually know that point before, guys, so I did cheat a little to make the graph look nice. So 1, negative 4 down here, and a local maximum here, negative 1, 0, local minimum 1, negative 4, and the complete cubic graph. That's the end of the question, guys. As always, thanks for watching. Feel free to like and subscribe, and good luck with methods.